The Harvey H. Jordan Award, I think we could fairly call the College of Engineering's valedictorian student. We have many exceptional students in the college, and it's hard to pick one, but on the other hand, I think when you hear who we picked, you'll understand that there are some great choices available. Harvey Jordan served for many years as a professor of general engineering and associate dean in the College of Engineering. This award recognizes the scholastic achievement and character of an outstanding senior. The recipient this year, Lucas B. Edelman. Luke. So, Luke is a senior in bioengineering with a minor in chemistry. For the last 2 years, he's been doing research with Professor Nathan Price in the Institute for Genomic Biology, applying computational tools to analyze genetic systems of different human cells and tissues, especially cancer. He's worked with Professor Brad Sutton in the Department of Bioengineering on research in magnetic resonance imaging. He's also worked with Professor Guy Weinberg at the University of Illinois Chicago College of Medicine on medical interventions for heart disease. In his spare time, he's been served as president of the Biomedical Engineering Society. He's scientific director and co-founder of the International Genetically Engineered Machine Team for the University of Illinois, which won a bronze medal in its first outing. He's done many volunteer activities, including the Kids in Chemistry Science and Outreach Program. Lucas is a recipient of the Gates Cambridge Scholarship from the Bill and Melinda Gates Foundation, the Churchill Scholarship from the University of Cambridge, the Goldwater Scholarship, which is one of the most competitive national scholarships, and following graduation, he'll begin doctoral studies in molecular biology at the University of Cambridge in the United Kingdom. So congratulations to Luke. Right. And also part of the Harvey Jordan Award is you get a chance to make a short address to the group, so here he is.
Thank you so much for those very kind words, Dean Tucker. Very few of them were true, but I'm honored to be up here. I'm actually really honored to be up here. I was flipping through the book and saw the very impressive records that everybody here has. So I'm pleasantly surprised and humbled to be up here as well. I'd like to say first before I start out, and this is a very long speech. I've got like 35 pages here, so you guys can hang in there. If there's anything that leads to the success of students in an institution like this, it's the students, but it's also the mentors on this campus. I've had the great fortune to work with some really fantastic mentors at this institution, at the Chicago campus of the University of Illinois, and if there's something that leads to our engagement in engineering and in science, I think it's the faculty members that guide us through it. So I would say that we should just offer every faculty member here a round of applause for that. So I've been asked to offer a student's perspective on the college experience. En route to grad school, I believe I'll be a student until roughly the 23rd grade. So this is a world I am becoming intimately familiar with and one I feel honored to speak about with you today. I'll focus on a couple of things I've learned as a bioengineer on this campus. Since Charles Darwin first published his theory of natural selection, biologists have been searching for the rules that govern how generations inherit traits from those before them. With the discovery of DNA, scientists thought that this matter was resolved. This elegant molecule encodes all of the information that composes life. It's passed from parent to child and sets forth the kinds of creatures we each grow into. But it turns out that this genetic hypothesis, that we are products of nature and that nature is in our genes, is not fully true. In fact, biologists are discovering that equally important in determining who we become is everything outside of our genes, our culture, our environment, our behavior. Our fate is not decreed by a single unchanging molecule. Rather, we are products of a complex physical and experiential mix where Our world is in dialogue with our genes. This is a powerful idea because while we can't change what's in our genes, we can certainly change our behavior. This is also powerful because never before have our institutions and our culture been more dynamic, open, and malleable. The DNA of the broader human project, its tribes and traditions, has never been through more rapid evolution. And students of the modern world are better equipped than ever to study this swiftly changing genetics of everything, of industry, technology, culture, science. And with this study, we hope, more able to engineer a better planet that the generation next will inherit. The student graduating college today experienced Google and YouTube and Twitter. We saw cloning and the sequencing of the human genome, space stations and solar power and iPods and hybrid cars. The remarkable thing is that these things are unremarkable. As kids, we grew up accustomed to this tempo of advancement and discovery. We weave this frenetic and ceaseless change into our worldview and our moral framework. To us, what is familiar is the novel. What is strange is things standing still. Students today welcome different types of people, traditions, and ideas as much as we do novel technologies. We sample experiences and ideas with little deterrence from geographic or cultural boundaries. We harbor no fear of the unknown or the unfamiliar or the different. We see more of the world, more diversity of experience and thought, and this too is integrated into our understanding of the human condition. We embrace the great rugged variety of America and the earth. We embrace friends of widely disparate backgrounds and orientations because we believe that good and wisdom brook no demographic border. We've been conditioned by unavoidable complexity in our daily lives to thrive in a convoluted and heterogeneous world. This trajectory towards flexibility is a good and necessary adaptation. In this era of natural selection's darkened final product, we should be prepared for change. Extinction is perhaps a basic precondition of an evolving world. And to be sure, we observe today a time of rapid and widespread extinction of institutions, of ideas. We witness companies consumed by those larger and more powerful, systems of economic and political thought outcompeted for resources. Governments, local and national, beliefs, personal and societal, subject to forces greater than their own. Biologists tell us that many times more species have ever gone extinct than exist in the world today. We wonder how to abide this violent turnover, this unending battle that begets so many victims. We wonder whether we too might one day be victims. But biologists also tell us that from extinction, new opportunities are created for growth and development, new opportunities that enable a better ecosystem, a better version of the tree of life. As we enter the, quote, real world, we should dare to recognize this and seize the vast open potential before us. We possess the tools, technologic and academic. We hold the intellectual curiosity and the personal engagement, the global and historical awareness. We will pioneer new science and technology and culture. We will improve old institutions, and we will start new ones. We will forge new grand paradigms from engineering to biology to business. We envision a peaceful and prosperous future driven ever forwards by technical innovation and a global partnership. Of course, we will all know hardship, but we will persevere. Our embrace of evolving DNA in ourselves and our wider world invites limitless possibility. Thank you.